So we need to calculate the bond angle of HNH in the compound NH3. So this means we're going to draw the Lewis structure for this compound. So the N is going to be the central atom because it is the most electronegative and there are more hydrogens, which means they'll end up surrounding this. So we're just going to connect the hydrogens by single bonds to this nitrogen. The valence of nitrogen is 5. We can find this out from the periodic table because the valence of fluorine is 7, the valence of oxygen is 6, the valence of nitrogen is 5, the valence of carbon is 4, boron 3, and then two, 1. So if the valence is 5, that means that it needs to have at least 5 bonds surrounding it, but it should also fulfill the octet rule. So we think of these bonds as individual electrons. Each H is only supposed to have 1 electron because it has a valence of 1, so all of the H's are fulfilled, but nitrogen has 1, 2, 3, so we need to add a lone pair to make the valence equal to 5, and this still fulfills the octet rule because it's 1, 2, 3, 4, 5, 6, 7, 8, because you would count both electrons in the bond. Basically, this N has 4 things attached to it, but only 3 of them are bonds. And when something only has 3 things attached to it and all of them are bonds, its angle is 120. But since there are 4 things and only 3 of them are bonds, but one of them is a lone pair, this lone pair is going to push against these bonds and make them closer together, which means that the bond angle is going to be just below that at 109.5.